repair. This definition is appear in the International Civil Aviation Organization, airworthiness of aircraft. First, we need to define what is repair. Repair, the keyword is restore. If we have damage, you restore. If you are damaged, if you go back to this mechanics material that we have learned earlier, stress is force or load over area. As you damage the structure, your area becomes smaller. As the area becomes smaller, the stress becomes high. So when you have damage on the aircraft structure, your area becomes smaller. Potentially you have stress, higher stress, because your area is small. So those are what higher stress. You have, again, if the stress is too high, if the stress is reaching the strength of the material, the structure will fail. So that's the damage. So you want to repair that. The repair is to restore. To restore means to recover the strength of the structure before it's damaged. So that is the definition. The main definition of repair is restore. Restore whatever has lost. What has been lost is the strength. Why? Because the stress is high due to the smaller cross-sectional area, causing the stress to go up. So you want to bring down the stress to the level almost similar to the condition before it was damaged. So first terminology here is repair. Repair means restore. So most standard repair, what you can see in the field or in the mainly in the aircraft structure repair manual, the repair, restore by repair is by installing doublers. So you cannot run away. If you look at the manual, you always see the structure repair manual always explain the restoration, which is the repair using a doubler. So your role is repair engineer to determine what is the thickness for the doubler and how many fastener that you use, what are the material you choose as a doubler, what material, what are the type of rivets you use as a fasteners, how many of them. So those are typical standard tasks of engineer doing repair. However, the beauty of aircraft structure design, it has manual for everything. So most of these repair are already covered in the structure repair manual. However, there are some area which is not covered. That is where you come in to design a new repair based on the guidance given in the structure repair manual. What you need to do, you need to first determine the load. What are the load? What are the load? How many load? How much has been lost due to defect? And then you need to recover the load. Remember, repair, define, restore. And how you calculate how many, what has been lost. You need to calculate the strength. You need to calculate the thickness of the doubler, enable for the doubler repair to take out the load. And also you need to determine the material of the doubler and the type of fastener, how many number of fastener. So what's shown here is the typical repair of shaft structure defect. And you see there's a doubler, there is a fastener, and there are rows, they are pitched. So you have to calculate the number of rows and the distance, the pitch distance. So this is typical repair for aircraft structure. And We are repairing it because it was damaged. So what has been damaged? So there are about 12 classification of damage. It could have been abrasion, corrosion, crack, creases, delaminations, dent, disbond, gouge, holes, nick, punctured, scratches. Those are type of damages. And those damage has to be inspected, has to determine the extent of damage, has to determine whether it's repairable, non-repairable, is major or minor repair required. So the structure damage again, you can see is punctured, then punctured because maybe something hit on it and caused the structure to puncture. Maybe there's a crack because the aircraft has been through heavy landing or have been through turbulence. The structure experienced overload and it become cracked, or it cracked because the structure has been around for many years and the aircraft become aging and some of the microstructure is failing, and that's also can cause a crack, or maybe crack because of corrosion, and some structure broken off because again heavy landing or something hit on it. Corrosion, obviously the most common problem in the structure. As the aircraft been serviced, they are being parked outdoor, the moisture build up and the corrosion has started. The dent could be cause of hitting or something, and normally for example you look at the radome, mostly radome area fail due to the bird strike. So the bird hit the dome, the whole dome is punctured, or the whole dome basically fail. So those are the typical damages. And corrosion, again corrosion is very common. As long as you got metal, non-metal also corrosion, like carbon with the contact of aluminum can cause corrosion. So corrosion is very serious situation, and most corrosion has to be repaired, and any part experience corrosion, it must be completely removed, and when you remove you also need to determine whether there are any potential corrosion to grow again. So you have to thoroughly inspect the parts after the corrosion be removed to ensure no more remaining corrosion, potential corrosion left. It's impossible for us to prevent totally the structure from corrosion. We will start corrosion, but we should not let it happen from what the defect that you found. And obviously, you should have removed everything. Lightning strike is one of the issue as well, because as the aircraft been flying, they hit by lightning, and some severe lightning strike maybe burn the part of the fuselage, puncture it, and most common burn lightning strike that I see, and they're only minor damage, just like pitting corrosion on the parts, and you have to inspect whether that defect is significantly degrade the structure. Aging issue, if you maybe not within your time, about 20 years ago, I was aircraft flying in Hawaii, and took off, and suddenly the top portion of the fuselage disappeared, cracked through and lost. And miraculously, only one been sucked out from the aircraft. The rest survived, as the captain and the co-pilot able to handle the aircraft and land safely to the airport. So it was a very interesting event, a very interesting incident, because from here they start to understand about aging aircraft, and they also start to understand there is micro crack grow between the rivets, and the crack grow between rivet to rivet, unzip the whole part of the fuselage structure. So they call it, those micro crack, they call it multi-site damage. So those are crack. We also need the competency and stress, because we need to calculate as the crack grow between rivet to rivet, and how much stress has been built up around the area, and it continue and it failed because the strength is so high, it's very high against the material strength. Another thing is fatigue. The previous Aloha also fatigue. It's also another fatigue. The whole aircraft flying and suddenly the top portion of fuselage punctured. It's not as severe as the Aloha, however, it's still very severe because it cracked through between the frames. So it's a large crack. Can also puncture the fuselage. This is fatigue. And operational damage, aircraft may hit the truck hit the aircraft hit another aircraft. That's also the source of damage on the structure. Turbulence also can cause damage. As a structure flying, the hit the turbulence, and the turbulence was so severe, and the load is so severe, and it can damage internally the aircraft structure, part of the aircraft structure. It can cause severely damage. So that is another source of potential structure failure. And the damage category, there are three. Either allowable, mean that damage is acceptable and it does not degrade the structure, and then maybe the repair is repairable, the damage is repairable, or maybe the repair is only by replacement of part. So this is how the OEM define it: allowable damage, repairable damage, and replacement of damaged part. What you need to do, you have to, as you receive the report of defect, you have to do thorough inspection on the defect, and if the defect require further detailed investigation, inspection, the aircraft has to be brought to the hangar, has to be put has to be jacked, put in shore, and put in a proper tracer, so that the aircraft condition is relaxed back to the OEM where it was manufactured, so it will not cause any stresses, which will be easier for us to look at the aircraft alignment and symmetry. Alignment and symmetry is very important because if the aircraft been distorted, you will be able to read it through this alignment and symmetry check. Any damage to the aircraft may cause distortion, especially for major damage, distortion or become unsymmetry. And you have to do the alignment symmetry check for heavy landing for aircraft suspected experience major damage. And you have to get the inspection detail from manual, and also the dimension of alignment symmetry check also given in the manual. So you have to put the aircraft in shore. So this is how they show the aircraft, alignment symmetry check, examination of damage. And in order to examine the damage, you have to remove all the unwanted material, cut out all the broken area, broken pieces, and if possible, you remove all the loose rivets. So first, by doing that, you're able to see clearly the damage, the extent of the damage. It could be affect other area. It could be not just local area. It could be also affecting the secondary structure. And loose rivets or rivets with the missing heads also indication the structure has gone through severely overloading, and the rivets heads been sheared off. So damage, again, there is a area, this is alignment symmetry, the damage also in the manual. Okay. Damage can be categorized into 3 or 4: mechanical action, chemical, chemical, thermal action, or cycling. So normally that what we experience is mechanical action due to like overloading or struck hitting on it. And what we can consider in doing the damage inspection, assessing the damage, detailed assessment of the damage, you have to consider aerodynamic smoothness, because most aircraft are very sensitive to the aerodynamic smoothness because especially for aircraft has been certified to RVSM which allow the aircraft to fly near to each other, and they need to have very good clean aircraft for them to able to get a good airspeed reading, and we do not want to disturb the area where they read the airspeed, because erroneous airspeed can cause aircraft either become too close, which is a danger for aircraft. So therefore, an aircraft structure manual has given you the sensitive area, the area where it's very critical to the aerodynamic, critical to smoothness. So, and for us to do the repair, we have to remember this area, and we have to make sure any repair done on this area will still comply with the aerodynamic smoothness requirement. So again, damage, repairable, non-repairable, allowable, and repairable. They got allowable. They have no repair, no inspection, just use as is. No repair but require inspection. You do not have to repair the structure, but you have to develop inspection program to inspect the damage. If the damage grew to a critical length, which is endanger the aircraft, then we have to do the repair. And then you have the Cat C, which repair and inspection. You have to do the repair at the same time. You make sure the repair is good. You want to monitor the repair performance. You also do the inspection. Okay, all the details are in here, so you can go through yourself. This is in the VLE. So you have to do damage report. When you do the inspection, you do the detail on the investigation and determination of the damage. You have to publish the report. The report is in the format. This is an example report by EASA, by Airbus. So the report have 5 components: aircraft data, the detailed aircraft, serial number, aircraft manufacturing number, aircraft tail number, owner, operator, all the detailed aircraft. Then component data, what are the components affected? If possible, you also need to state the part number, describe and state the part number of the part. Inspection data, what inspection has been done, how the damage was found. So you need to explain the type inspection been done, where you can find the damage, and detail the damage, the length, the depth, the width, location. You have to explain it there, as well as you also need to explain, need to tell them what is your requirement, why you need to write those default, why you need from OEM. This report goes to OEM, and you have to tell OEM what do you want actually, why you come out with the report. So the details are here. So this is typical repair. You have doublers, you have fillers, and we will go through it in more detail later on. So basically, I can probably stop here. So what we're trying to do today, what we have learned today is we need to go back to mechanics material. We need to go and review, because whatever we do here mostly will go back to the mechanics material, where you need to determine the load. You calculate the stress by dividing the load to the cross-sectional area, and the stress you compare the material strength. The material strength measured in the unit of stress. For aircraft structure, anything higher than lower than 1.5 factor of safety is not acceptable. The aircraft become not airworthy. Whatever you design, you must design it below 1. For safety factor 1.5 and above. And also we have to do detailed inspection on the defect. You have to write inspection report, and the report should be structured in the way that we are able to write a paragraph for each section, and for us to write to OEM, and you are seeking assistance from OEMs, especially whether you need to get your repair endorsed, repair approved, or if you are not able to do the repair design, you want to get them to provide you with the recommended repair. Any questions so far?
I think so far.
Sir,
So
is
good.
it good, sir?
So far so good. I will prepare a quiz for you to do over the weekend about the week 1 and 2. So this is the first quiz online.
Sir, it will be about this chapter, right, sir? About the
Yes,
structure repair.
about what I have talking about last week and this week.
Okay, sir.
Alright, so please do because everything will be in a vary, so the marking will be from there as well. So, alright. So I'll set a quiz for you to do complete before next class. Okay, anything, please WhatsApp message me if you got any problem with any other subject. Hopefully you can follow. This is the best I can do for you at the moment. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good afternoon.
Waalaikumsalam.
Thank you, sir.
Thanks a lot, sir.
Thank you, sir.
Thank you, sir.
Excuse me, sir.
Yeah.
My name is Abdullah Akil. I couldn't